Hey everyone, welcome back for another deep dive. Today we're taking a closer look at something I know you're all dealing with in your practices.
Endocrine-disrupting chemicals, EDCs.
EDCs, right? It feels like everywhere you turn lately, there's another study, another headline about the impact they're having on our patients. And it's a lot to unpack. So we've got a stack of research articles here, reports, clinical studies, some pretty dense stuff,
hmm
all focused on how these EDCs are impacting endocrine function and what it means for us as endocrinologists.
Yeah, it's a real challenge because these EDCs, they're not just one thing, right? We're talking about a huge class of chemicals. They're everywhere in our environment.
Exactly. It's like they've become part of the fabric of modern life, which makes it even more challenging to pinpoint their effects.
Right. And they work in so many different ways. They can mimic hormones, they can block hormones, they can even interfere with the way our bodies produce and metabolize hormones. It's a
hmm
bit of a minefield.
Absolutely.
Yeah.
So let's start with the basics for our listeners who might be thinking, okay, EDCs, I've heard the term, but remind me again, what exactly are we talking about?
So in the simplest terms, EDCs are exogenous substances that interfere with the way our hormones work. They disrupt the endocrine system, which, as you know, is responsible for so many vital functions in the body.
Right, everything from growth and development to metabolism, reproduction, mood even.
Exactly. And these EDCs, they're sneaky. They often work at very low doses, and their effects can be subtle and long-lasting. It's not always a clear cause and effect relationship, which makes it even more challenging to study and diagnose.
It's like trying to solve a puzzle with some of the pieces missing. And what makes it even more complicated is that we're all exposed to multiple EDCs at the same time. It's not like you can isolate one and say, okay, this is the culprit.
Exactly. It's a cumulative effect, and
Mhm.
that's what makes it so difficult to pinpoint those connections between exposure and specific health outcomes.
So we've established that EDCs are everywhere, and they can disrupt the endocrine system in a myriad of ways. But let's get down to brass tacks. Here we are, endocrinologists on the front lines, dealing with these complex cases day in and day out. What are some of the key EDCs that we should be aware of, and what are their specific effects on endocrine function?
Well, I think one of the most well-known and well-studied EDCs is bisphenol A, or BPA.
BPA, oh yeah, the one that's always in the news. It's everything from plastic water bottles to food packaging.
Right, and it's a xenoestrogen, which means it mimics the effects of estrogen in the body.
So it binds to estrogen receptors and can disrupt hormonal signaling pathways.
Exactly. And studies have shown that BPA exposure is linked to a wide range of health issues, including reproductive problems, metabolic disorders, even certain types of cancer.
It's pretty alarming when you consider that studies have shown that BPA is detectable in over 90% of the U.S. population.
Yeah, it's a ubiquitous chemical, and it's one that we really need to be paying attention to as endocrinologists.
Absolutely. And it's not just BPA. We've got phthalates, which are commonly found in personal care products like lotions and shampoos, and they've been linked to reproductive issues and thyroid dysfunction.
And then there's atrazine, which is a widely used herbicide that's been shown to disrupt hormonal signaling in amphibians, and there's growing concern about its potential effects on human health as well.
So we've got these imposters, these xenoestrogens like BPA and phthalates messing with estrogen signaling pathways. And then we have chemicals like atrazine that can disrupt a whole range of hormonal processes. It's like a constant barrage of interference.
It is. And what makes it even more concerning is that we're still uncovering the full extent of the damage. We're learning more and more about the long-term effects of these EDCs, and it's not always a pretty picture.
No, it's not. So we've touched on some of the big players like BPA phthalates and atrazine, but what about some of the lesser known EDCs? Are there any that are particularly relevant to our work as endocrinologists?
Well, one that's particularly interesting is tributyldin, or TBT.
TBT.
Yeah.
Okay, I'm not familiar with that one.
It's an organotin compound that's been used as an anti-fouling agent in paints for ships and boats.
Okay, so how does it fit into the EDC picture?
Well, TBT is what we call a metabolism disrupting chemical, or MDC. It specifically targets metabolic pathways, and it's been shown to have obesogenic effects.
Obesogenic. You mean it can actually contribute to weight gain?
Yes, that's right. Studies have shown that TBT can increase the number and size of fat cells, and it can interfere with the way our bodies regulate energy balance.
So it's not just about calories in, calories out. It's like TBT is hijacking our metabolism, making it harder to maintain a healthy weight.
Exactly. And what's even more concerning is that TBT can act on multiple levels. It can disrupt hormonal signaling in the brain, and it can directly affect adipose tissue.
So it's a double whammy, messing with our hormones and our metabolism at the same time.
Right. And it's not just TBT. There are a number of other EDCs that have been linked to metabolic disorders like phthalates, BPA, and certain pesticides.
So this is a major concern for us as endocrinologists. We're seeing more and more patients struggling with obesity and type 2 diabetes, and now we're learning that EDCs could be playing a role in these epidemics.
It's a complex issue, but I think it's important for us to be aware of the potential link between EDC exposure and metabolic dysfunction.
Absolutely. It adds another layer of complexity to our diagnoses and treatment plans.
It does. But I think the key takeaway here is that we need to start thinking about environmental exposures as potential risk factors for endocrine disorders. It's not just about genetics and lifestyle anymore.
Right. It's about taking a holistic approach and considering all the factors that could be contributing to our patients' health problems.
Exactly. We need to be asking the right questions, taking detailed environmental histories, and educating our patients about the potential risks of EDCs.
Okay, so we've got these EDCs messing with our hormones, our metabolism, and who knows what else. We're starting to get a sense of the scope of the problem. But where do we go from here? What can we as endocrinologists do to address this issue?
Well, I think the first step is awareness. We need to educate ourselves about the latest research so we can recognize the signs and symptoms of EDC exposure in our patients.
Right. We need to be able to connect the dots between those subtle changes in endocrine function and the potential role of EDCs.
Exactly. And once we have that awareness, we can start having those conversations with our patients. We can counsel them on ways to reduce their exposure, and we can advocate for policies that protect endocrine health.
It's about empowering ourselves and our patients to make informed choices about the products we use, the foods we eat, and the environments we live in.
Exactly. We have a responsibility to be proactive and to use our knowledge to make a positive impact on the health of our patients and our communities.
I completely agree. This is a call to action for all endocrinologists out there. We need to step up and be leaders in this fight against EDCs.
We do. It's a challenge, but it's one that we can't afford to ignore.
And on that note, let's take a closer look at one of the most concerning impacts of EDCs fertility.
Right. We are seeing some pretty alarming trends.
Definitely concerning. Let's dive in.
It's a sensitive area, but one we can't shy away from.
Absolutely. When we're talking about EDCs and their impact on the endocrine system, we can't ignore the elephant in the room, declining fertility rates.
It's a global trend, and the research is pointing towards EDCs as a significant contributing factor.
And it's not just about difficulty conceiving. We're talking about the potential for long-term effects on reproductive health.
Exactly. We're seeing a rise in developmental abnormalities in male offspring, like hypospadias and cryptorchidism, and these can have lasting impacts on fertility later in life.
It's like these EDCs are throwing a wrench into the delicate machinery of human reproduction.
They really are, and they're doing it on multiple levels. Let's take phthalates, for example. They're ubiquitous in our environment, found in everything from plastics to personal care products.
And we know phthalates can disrupt testosterone production.
Precisely. They interfere with the hypothalamic pituitary gonadal axis, which is the control center for hormone production.
So it's not just about the tests themselves, it's about the whole hormonal cascade that regulates sperm production.
Right, and we see that reflected in studies showing that phthalate exposure is linked to reduced semen quality, lower sperm counts, decreased motility. It's a whole spectrum of issues.
And it's not just quantity, we're talking about quality too.
Exactly. Phthalates have been shown to damage sperm DNA, which can lead to infertility and even increase the risk of birth defects.
So these chemicals are not only affecting the current generation, but potentially future generations as well.
That's the scary part. We're just beginning to understand the true scope of their impact. And it's not just phthalates. We're seeing similar effects with other EDCs like PCBs and certain pesticides.
It's like a multi-pronged attack on the male reproductive system.
And unfortunately, the female reproductive system is not immune either.
We've seen some pretty dramatic examples of that in the past.
Right. DES, diethylstilbestrol. It's a synthetic estrogen that was prescribed to pregnant women in the mid-20th century to prevent miscarriages.
A classic case of good intentions gone wrong.
It turned out that DES exposure in utero had devastating effects on the reproductive health of daughters, leading to a higher risk of infertility, cervical cancer, and other reproductive abnormalities.
A real tragedy and a stark reminder of how potent these EDCs can be.
And the effects of DES weren't limited to the first generation. We're now seeing reproductive problems in the granddaughters of women who took DES.
It's heartbreaking to think that these chemicals can have such long-lasting and far-reaching consequences.
It's a wake-up call for us as endocrinologists. We need to be aware of the potential impact of EDCs on fertility, and we need to be proactive in protecting our patients.
So what does that look like in practice?
Well, for starters, we need to be asking our patients about potential exposures, taking detailed environmental histories.
It's like adding another dimension to our patient assessments.
Exactly. We need to be thinking about not just their medical history, but also their environmental history.
And once we have a better understanding of their exposures, what can we do?
Well, there are a number of things we can recommend to help reduce exposure. Things like choosing BPA-free products, filtering water, eating organic foods whenever possible.
It's about making those everyday choices that can add up to a big difference.
Right. And it's also about advocating for policies that limit the use of harmful chemicals and protect public health.
So it's a two-pronged approach, individual action and systemic change.
Absolutely. We need to be working on both fronts if we want to truly address this issue.
It's a daunting task, but I think we're up to the challenge as a community of endocrinologists.
I agree. We have the knowledge and the expertise to make a real difference in the lives of our patients.
And speaking of making a difference, I think it's time we address another area where EDCs are causing concern, puberty.
Yeah, we're seeing some pretty alarming trends there as well.
Definitely trends that are relevant to every endocrinologist out there. Puberty, that delicate dance of hormones that marks the transition from childhood to adulthood. It's a process we as endocrinologists know intimately, but it seems like EDCs are disrupting that delicate dance.
It's true. We're seeing cases of precocious puberty where puberty starts earlier than expected, and also cases of delayed puberty where it's starting later.
And it's not just a matter of timing. We're talking about potential long-term consequences for reproductive health, metabolic health, even bone health.
Exactly. EDCs can interfere with the hypothalamic pituitary gonadal axis, which is the control center for puberty. They can disrupt the production and release of key hormones like gonadotropin-releasing hormone LH and FSH.
So it's like they're throwing a wrench in the works at the very foundation of the process.
Precisely. And the effects can be subtle and long-lasting. It's not always a clear cause and effect, but the research is mounting.
What are some of the specific EDCs that have been linked to puberty disruptions?
Well, one of the most well-studied is BPA.
Yeah.
We've already talked about its effects on estrogen signaling, but it can also interfere with androgen signaling.
So it's not just a female hormone disruptor. It can mess with male hormones as well.
Exactly. Studies have shown that BPA exposure is linked to precocious puberty in girls and delayed puberty in boys. It's a real concern.
And then there are phthalates, those ubiquitous chemicals found in plastics and personal care products. They've been linked to precocious puberty in girls as well.
Right. And there's also some evidence linking certain pesticides to delayed puberty in boys. So it's a complex picture with multiple EDCs potentially contributing to these disruptions.
It makes you wonder what's going on in those critical developmental windows when these hormonal shifts are happening. Are we inadvertently exposing our children to these chemicals at the most vulnerable times?
It's a valid concern and one that we need to be taking seriously as endocrinologists.
So what can we do? I mean, it's not like we can shield our patients from every potential EDC out there.
No, we can't, but we can educate ourselves and our patients. We can make informed choices about the products we use, the foods we eat, and the environments we create for our children.
It's about minimizing exposure whenever possible.
Exactly. And it's also about advocating for policies that protect public health and limit the use of harmful chemicals.
So it's a combination of individual action and systemic change.
Absolutely. We need to be working on both fronts if we want to safeguard the endocrine health of future generations.
Well, this deep dive has certainly been a journey. It's eye-opening to see the extent to which EDCs are impacting our patients' lives, and it's a call to action for all of us in the endocrinology community.
I agree. We need to stay informed, stay engaged, and continue to advocate for our patients and for a healthier environment.
It's clear that EDCs are a major challenge, but it's also clear that we have the knowledge and the resources to make a difference.
We do. We just need to keep pushing for change.
Thanks for joining us for this deep dive into the world of EDCs and their impact on endocrinology. Hope you found it informative and empowering.
It was a pleasure being here.
To all our listeners out there, thank you for your dedication to the field of endocrinology and your commitment to your patients. Keep asking questions, keep learning, and keep fighting the good fight.
We're in this together.
Until next time, stay curious and stay well.